Hello everybody, welcome to our channel ChemE Simplified. Today we are going to discuss an interesting topic, fluid flow and its types. So moving towards our today's lecture, first we will have its basic introduction. So what the fluid is? A fluid is defined as a state of matter in which its molecules move freely and do not bear a constant relationship in space to other molecules. The next point to be discussed here is that in physics, fluid flow has all kinds of aspects: steady or unsteady, compressible or incompressible, viscous or non-viscous, also rotational or irrotational, to name a few. Some of these characteristics reflect properties of the liquid itself, and others focus on how the fluid is moving. Fluids are liquids like blood, gas like oxygen, vapors transition from liquid to gas, sublimate transition from solid to gas by passing liquid state. These are the forms of fluids. So the next is, how do we define flow? So what's the definition of flow? Flow is defined as a quantity of fluid, either gas, liquid, vapor or sublimate, that passes a point per unit time. Means flow is quantity per unit time. Flow is sometimes written as delta Q, means the rate of change of flow or rate of change of a quantity. Okay, moving on. The next we are going to discuss is about the types of fluid flow. So what the basic types of fluid flow? We have laminar flow, transition flow, turbulent flow, compressible flow and incompressible flow. That will be discussed further one by one in detail. So the first one is laminar flow. Laminar flow is also known as streamline flow. It occurs when a fluid flows in parallel layers with no disruption between the layers. This flow is majorly at low velocities. At low velocities, the fluid tends to flow without lateral mixing and adjacent layers slide past one another like playing cards. There are no cross currents perpendicular to the direction of flow, nor eddies or swirls of fluid. In laminar flow, the motion of the particles of the fluid is very orderly, with all particles moving in straight lines parallel to the pipe walls. We can say that laminar flow is a flow regime characterized by high momentum diffusion and low momentum convection. We can also measure that either the flow is laminar or not by Reynolds number. If the value of Reynolds number for a fluid flowing is less than or equal to 2100, then the flow is laminar. The second type is transitional flow. Transition flow is a mixture of laminar and turbulent flow, with turbulence in the center of the pipe and laminar flow near the edges. Each of these flows behave in different manners in terms of their frictional energy loss while flowing, and have different equations that predict their behavior. Also, the transition flow can be determined by Reynolds number. If the value of Reynolds number for transition flow is 2100 to 4200. And moving on, the third one is the turbulent flow. In turbulent flow, vortices, eddies and waves make the flow unpredictable. Turbulent flow happens in general at higher flow rates and with larger pipes. In turbulent flow, shear stress is a function of density rho. Like laminar and the transition flow, turbulent flow can also be found by finding the Reynolds number value. If the value of Reynolds number is greater than or equal to 4200, then we can say that the flow is turbulent flow. The next type of the fluid flow is compressible flow branch. Compressible flow is the branch of fluid mechanics that deals with the flows having significant changes in fluid density. Gases, but not liquids, display such behavior. We can say that the study of compressible flow is relevant to high-speed aircraft, jet engines, rocket motors, gas pipelines, abrasive blastings, and many others like this. The last type to be discussed is incompressible flow. So incompressible flow, what the incompressible flow is? In fluid mechanics, or more generally continuum mechanics, incompressible flow, which is can also be said as isochoric flow, it refers to a flow in which the material density is constant within a fluid parcel and infinitesimal volume that moves with the flow velocity. Or we can also say that an equivalent statement that implies incompressibility is that the divergence of the flow velocity is zero. Thank you so much. This was today's lecture. Hope you all get all the points. If you liked the video, please don't forget to give it a thumbs up and subscribe to our channel Chemistry Simplified. Thank you so much.